Geometry, Patterning, and Algebraic Reasoning 2.1. We're going to look at a definition of polynomial, and this is going to look confusing, this right here. Don't worry about that so much. We're going to focus on having whole number variable exponents. Whole numbers being numbers 0, 1, 2, 3. That's easier to think about than having to sort of sort through all these variables. Let's look at some examples and non-examples of polynomials. Here, our variable, as long as it's in a standard position and has a whole number variable exponent, you're good. So x here has a variable exponent of 1. Here, -9, you don't see x at all. This technically is -9, x to the 0 power. So if you don't see the variable at all, it has power 0. If you do see the variable, but no exponent, it's understood to be 1. 1 and 0 are both whole numbers. You're good. Another example, variable exponent is 2, 1, 0. So you're good. Here it's just a constant or number, -12. But again, x to the 0. 0 is a whole number, so you're good. And 1, 3, 0, 2. Those are all whole numbers. This time it's not in order, but that's okay. It's still a polynomial. Some non-examples. If x is in an unusual position, like the denominator, it's not a polynomial. The reason for that, you may or may not know, x has a -1 exponent here. That's not a whole number. So if any variable does not have a whole number exponent, it's not a polynomial. Here, x is being raised to the 1/2 power. That's what square root means. You may not know that here, and that's okay. Just remember, if x is enclosed in any kind of special symbol other than the ordinary parenthesis, it's not a polynomial. And obviously pi is not a whole number, so that would not be a polynomial. So the red highlight shows why these three are not polynomials, and these four over here are all polynomials. Some vocabulary associated with polynomials. We have degree, leading coefficient, and constant term. The degree is the highest variable exponent, so it's colored in red here. It's 2. 2 is bigger than 1 and 0. The leading coefficient is actually not mentioned in the literature to this standard, but it always goes with degree, so I'll mention it here. The leading coefficient is the number in front of the highest power. So 6 is in front of the highest power too. So 6 is your leading coefficient. It's not the other two. And constant term is the term that has no variable. Remember, that means power 0 on the variable. So 3, colored in green, is your constant term here. Sometimes you see more than one variable. Here we have both x and y. This is a bit unusual, but it is mentioned. The degree, surprisingly, is 5 here. And the way we get 5 is this. Within each term, if you have multiple variables, you have to add the exponents. So the degree here is 5. The degree on this one would be 3. The degree on this one is just 4. And for the entire polynomial, you have to take the highest of those. So it would be 5. So just a small kind of sidebar if you see that. Standard form would be when you have it in descending order for your variable exponents. Okay, so this would not be in standard form. Notice the variable exponents is 0. Remember, if you don't see x, it's 0. 2 and 1. That's not in order. But if I put it in order, 2, 1, 0, that's descending order, then it is in standard form. Notice the negative in this case goes with the 3x squared. It travels with it as you move it around. We do have name based on the number of terms. One term is called a monomial. 2 terms is called a binomial. You may be familiar with bicycle, binoculars, 2 wheels, 2 lenses. That prefix means 2. And tri, the prefix means 3, like Triceratops, the dinosaur with 3 horns, or tripod with the 3 legs for your camera, and so forth. If it has more than 3 terms, we just generically call it a polynomial with that many terms. For example, 4 terms you see here. Now, if you're not sure what a term is, we'll illustrate. Name the following. 8x minus 6. A plus or a minus sign separates terms. So this has 1, 2 terms. Therefore, it's a binomial. Here, you're separated again by minus signs. You could see a plus, but 1, 2, 3. This is a trinomial. One note here If you happen to have like terms, like let's assume this was 8x minus 2x instead of 8x to the fourth, you would combine those like terms before making the declaration. So if this was 8x instead of 8x to the fourth, it actually would be a binomial kind of in disguise because you'd have to combine them first. Okay, consider this polynomial. Put in the standard form. The variable exponents are not in order. Let's put them in descending order. Notice again the negative stays with the x. 3, 2, 1, 0. Identify the leading coefficient degree. That's easier to do once you're in standard form because it's in the front. The leading coefficient would be 7. The degree is 3. Remember, the 7, not because it's the biggest, but because it's in the front once arranged by variable exponent. And 3 is the highest variable exponent. The polynomial would be a polynomial with 4 terms. Interpreting expressions. Now this is sort of subtle in the standard, but in the supplementary material it's intended that a student should be able to match up a verbal expression with an algebraic expression. Write as an algebraic expression. Multiply a number by 2 and add 4. Okay. Well, that would be this. Multiply a number we'll call n, by 2 and add 4 to that. Or we could reverse that, write in words. We have to be careful with the parentheses. We could say something like multiply 8 with a number minus 2, instead of saying multiply 8 by a number and then subtract 2. So the wording would be particular there. The standard looks like this. Interpret, again, that word interpret there is a bit vague, but interpret polynomial expressions. Polynomial expressions we define. Expressions of varying degrees, so we define those two terms, that represent a quantity in term of its given geometric framework. Now, the geometry of this we'll get to in the next couple of videos, as it's not really important in this particular standard, but that is polynomials and leading into geometry.